Hey, D. Dykstra here with another video about math. This time we're talking about differentiation of log functions. Alright, so let's see, let's remind ourselves some of the properties of logarithms. Recall that if we have ln, this goes for a natural log or logarithms. Okay, so natural logs have a base of e, and logs can have base 10, natural base 10, or they can be anything else. So these properties, again, we learned back a while ago, whereas as ln of a times b, we can expand, right? We can expand this to ln of a plus ln of b. Then there's ln of a divided by b, and that is the division property. So multiplication, addition, division goes with subtraction, ln a minus ln b. And the power property is ln of a to the nth power. What we can do is we can bring that n down, and that will go in front of the ln, and so we get n ln a. And remember, ln with base e, natural base e of 1 is 0. We say e to what power is 1, and that's 0. So now let's look at the differentiation properties. Now I basically wrote it out in u form because oftentimes you're going to have some u in there. So what it is d dx, the derivative of ln of u, is equal to 1 over that u times u prime. All right? And this goes for the absolute value as well. Absolute value of u is equal to 1 over u times u prime. Okay, so check it out. Here we go. Example number 1. f of x is equal to ln 3x. All right? So now, if we just did the 1 over u times u prime, 3x becomes our u. So we put that in the denominator, 1 over 3x. We take the derivative of 3x, and that is 3. And then what we can do is we can simply cancel out these 3's here, and we get 1 over x. We can prove it another way if we use the log property of multiplication and expand it. This was ln of 3x, so we can rewrite this as f of x equals ln 3 plus ln x. Recall that when ln 3 is just it's a number, right? It's a constant. So the derivative of a constant is 0, so that's going to go to 0. And the derivative of ln of x is just 1 over x. All right, here we go. Example number 2. Example number 2. Let's say that h of x is equal to the square root of x squared minus 4. All right, so we can start off by rewriting this as h of x equals ln of x squared minus 4 to the 1/2 power. Recall that the radical is, we can move that to a 1/2 power. And then we use the power rule property. We can bring this 1/2 forward. And so we get h of x is 1/2 ln x squared minus 4. Now this is all together, so we can't expand this any further. It's not like we can write ln of x squared minus ln of 4. This does not get distributed. We cannot distribute. This is an argument inside the ln function. So we have to be careful not to take it the next step and start distributing. It wouldn't be right. So we'll go with the derivative straight from here. 1/2 is a constant, so it stays the same. We're being multiplied this. This will be our u in here, so that becomes 1 over x squared minus 4. Then we'll take the derivative of x squared minus 4, which is 2x. So now what we can do is we can go, oh, okay, well, the 2 in the denominator will cancel with this new 2 in the numerator, and so we'll get x times 1, or h prime of x, the derivative is x over x squared minus 4. All right? So pretty simple, basic, but just remember those properties. And here we go. Review one more time. The derivative with respect to x of ln of u is 1 over u times u prime. All right? Hope you've enjoyed that. Thanks again. D. Dykstra out. Have a great day. Show that one more time. There you go. See ya.